Hello everyone, this is Amit Kumar Singh. Welcome to my class. In this class, we'll discuss this question number 10 of exercise 4C from the chapter probability. So you can see this exercise. When it comes to this exercise, we'll get a lot of questions based on probability, and some questions are comparatively difficult than other. So one of the question where the student normally find difficulty in this exercise 4C is this question number 10. You can see in this question what is given. In this question, it is given that a data, a probably a histogram is given, where in this histogram they're talking about the frequency density. In the frequency density is all about the percentage of bus per minute, which given in the form of upper hand or the vertical axis, which you can see here, while the horizontal axis talking about the delay time of these buses. So if you observe this histogram, where here the x-axis talk about the delay time in minute for different buses, and the y-axis is talking about the frequency density. Okay, the what this frequency density is all about? It is about percentage of buses per minute. Okay, if you see the sum total of this histogram, this is 100%. You can see probably you can, if you just look into this diagram, so each rectangle what you see in histogram, it represent 5%. You can see it represent 5%. So if you count the number of histograms, probably the number of rectangle here, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So each each rectangle represent 5%. So altogether this is 100%. Okay, so in this question they're talking about two buses. In this question they're talking about two buses, and what we need to do in question number one, we need to find the probability that both the buses they get delayed by less than 4 minutes. Okay, so delayed by less than 4 minutes, you can see if this is 4 minutes, and so probably you can find 12 rectangles are there which coming under the data less than 12 minutes. Okay, so this represent uh, less than 12 minutes. This will represent less than, sorry, 4 minutes. So this represent less than 4 minutes. Out of 20 rectangle, 12 rectangle are representing the frequency where the buses are delayed less than 4 minutes. So so if you calculate the probability that one bus get delayed by less than 4 minutes, so that will be 12 by 20. Okay, so that I can say 3 by 5 for one bus, or that is 60%. So for two bus, the probability will be how much? So for two bus, for one bus, it is 60%, and the probability that the one bus will delay is independent of the probability that the other bus will delay. So for two buses, if I'm calculating the probability, so you can understand probability of A1 intersection of A2, that will be probability of A1 into probability of A2, where maybe this probability A1 means a probability that the first bus get delayed, and the probability of A2 means the probability that the second bus get delayed. So you can easily understand. So the probability that the both bus get delayed, probability that the both bus get delay, if you want to calculate the probability, that will be 60% is the probability for one bus to delay. So again 60% the probability that the other bus will delay. So the net probability is 36%. Okay, so this 36% you can write 36 by 100, or this is also equal to 9 by 20. Clear? Now, if we talk about the next question is all about where the scenario we need to develop where at least one of the bus departed uh, get delayed by more than 7 minutes. Okay, so two buses are there. What can happen with the two bus? That the first bus get delayed, second bus reach on time. It can be the the first bus reach on time, second bus get delay. Okay, it can be both bus get delay, it can be both bus get delay, or it can be both bus reach on time. So the sum total of this will be equal to 1. Clear? So here, like this means bus get delay, and this means bus reach on time. Clear, everyone? So if two buses are there, what can happen? Both the bus get delay, both the bus reach on time. First bus reach on time, second bus delay. First bus get delay, second bus reach on time. So for this question, what we need to find? We need to find at least one of the bus departed is more than 7 minutes late. So you can understand here. So delay means I'm talking about here. The delay means those bus which reach more than 7 minutes. On time, maybe suppose here means which reach before 7 minutes. Fine. So here we need to find the probability that at least one of the bus departed is more than 7 minutes late. So we need to talk about all these cases. So this is equal to, this is nothing but if this is equal to 1 minus the probability that 1 minus the probability 1 minus the probability that both the buses reach before 7 minutes. Can you understand? Before 7 minutes. You just need to find. So you can again understand these are independent event. Exercise 4C is all about the problems related to independent event only. So here for this case, before 7 minutes means you can count uh, 17 rectangle out of 20 rectangle. So before 7 minutes means 1 minus, before 7 minutes means 17 by 20. Again, they are independent event. So you can understand when the events are independent, you simply need to multiply them. 1 minus 289 by 400. So 289 by 400, this will be 111 by 400. If I'm not wrong. So this is 1.11 by 4, point 2, then 0.42 is 8, then 31, 7 is 28, 30 means 7 is 28.277. Okay, I hope I did directly. I hope you understood that both the events are independent. So the probability that the first bus reach before 17 minutes is independent that the other bus reach before 17 minutes, before 7 minutes, not 17 minutes. So and out to 17 rectangle out of 20 rectangle represent the scenario when the buses are reaching before 7 minutes. So you can easily understand that the probability that the bus reach before 7 minutes is nothing but it is 17 by 20. Clear, everyone? Anyone any doubt? Please ask you doubt if you have any. In by using the comment option, you can use the comment option. Let me know your opinion about the class. Thank you, everyone.